Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were doing our pattern wise DSA sheet, and in this we were doing stacks topic, and today we will start the third pattern, which is a stack simulation and undo operations. And we will see कि wherever we have to do all undo type of operation, how stack data structure will help us to basically simplify our solutions. So first we will do this backspace string compare problem. So let's read the problem statement. It says we'll be given two strings S and T, and we have to return true if they are equal when both are typed into empty text editors, where hashtag means a backspace character. Means, as you can see hashtag here, so one hashtag means we have to delete the previous one character. So after deleting the previous one character, it will become A and C. Definitely hashtag we won't count, so it will be AC. Similarly, if you do same in T string, so obviously hashtag will delete this D and it will also become AC. And as you can see, this AC and S, both strings are similar, means you have to return true. If not, then you have to return false. Very simple. But let's read the constraint. So constraint says S and T length can be minimum 1 and can be maximum 200. Okay, we are safer on side because the n is 200, very small. So n square code can also work, but it will be slower. So definitely we will optimize it and we will use stack data structure. But before we optimize, let's try to understand ki how can we do with simple brute force, like how everyone can think for this approach. So here, as you can see, once we reached out A, this is safe, correct? So we will not do anything. So let's say we will save in another string. String is immutable if you know, so we will save it in string builder, correct? But only in Java, okay? In Python you can simply make string. So let's say S1, there you will add A. Okay, now second character B, again obviously you will add B here as well. But now once you encountered hash, it means you have to delete the previous character, correct? From string builder S1, so you will definitely delete this. Okay, now hashtag, as it is hashtag, so definitely you will not add this. And now next character C, you will add C. It is very simple. So only O of n time complexity, right? No, actually what if there are characters like A, B, C, D, E, F, again A, B and all, and then hashtag, 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 like multiple hashtags together. Because once you encountered a hashtag, definitely you will go back and delete. Second hashtag, definitely you will go back and delete. Third hashtag, definitely you will go back and delete, correct? So forget about the time complexity, let's try to solve this in any way, okay? So that to understood ki we'll make a what? String builder, and whenever we encountered a hashtag, we will delete the previous character, correct? Okay. Now we'll apply the similar approach in T as well. We will add A, okay, in T1, which is string builder. Then D, obviously, once hashtag encountered, we will delete this D, correct? And now C added. After that, we can check if T1 and S1 matches, correct? Yes. Space complexity we used here. Because we have made a extra space which is string builder for S1 also and for T1 also. Can I say this? Yes. Okay. And we all know, we all have studied also ki whenever we are iterating towards forward, okay, and found something and we thought ki okay, we have to go back, either to find minimum, maximum, or here in case you have to delete, okay, but you have to traverse back, correct? So you already traversed forward and now you encountered hashtag, you again want to traverse back, traverse back. Here only one hashtag, so means only one time. But what if multiple hashtags? Then definitely multiple times you have to go back and again start from the same point. Can I say this? So don't you think you can use stack data structure here? So basically, let's try to code this, but you will see ki stack has not reduced the time and space complexity, but definitely the idea, it has made it simpler. Because the thing we are using now, this concept, we will go back and delete, that is nothing but stack, okay? So as A character is there, so we will, in S1 stack, we will add A. Once B found, we will add B. Once stack found, like this hashtag found, from our stack, we will delete the top element, okay? Now, next time C character will be appended. Similarly, in the T also, we will make a T1 stack here A added, D added, once hashtag found, D will get deleted, top element, and then C added. T1, S1, same, we can return true. Yes, it is very simple, right? Like here we don't need to worry about string builder and all. Correct. Okay. So we can definitely code for this. This is very simple code. Then wait, but is this optimized? Let me teach you, but first let's write the stack code. So what we will do, simply we will make a private build function and there we will send us one single string. So once we will do for S and second time we will do for T, and whatever string we will get, that later on we will check if they are equal or not. If they are equal, we will return true. If not, we will return false. But what we are doing in this function, first we will make a stack. One by one we will iterate in the character array, and if that character is hashtag, means we have to pop, but we can only pop if our stack is not empty. So if stack is not empty, then pop. But if the character is not hashtag, means any such character, then definitely we'll simply push in our stack. Now after coming back, whatever are there, like whatever characters are there in the stack, we have to retrieve it back and convert it into string. Can I say this? And as a string is immutable, so in Java we will make a string builder. We will add every character in that string builder, yes, and once found we will return that result by converting into toString, and then this function, like whatever it has returned, two strings, it will compare and it will return true and false as per that. Yes, time complexity, definitely O of n for this check or removal, and O of n to make this string builder. It's linear only. But if we talk about space complexity, definitely we are using the stack, and to convert the answer result, we are actually taking another string builder. Yes. So as you can see, it's still slower. Why? Because we are using extra space complexity. And definitely as the constraint is so small, so interviewer might expect you to optimize it further. Even though it's categorized in easy problem, but trust me, it has different logic to optimize it further. So the idea is very simple. As you can see, when we were going from left to right, correct, and once encountered this hashtag, we again went back to delete, correct. But this operation of undo is happening towards left side or right side? Yes, of course left side. So why don't we do one thing? We know that from right to left we are safe. Correct, because we have not added itself. Can I say this? We have not added. So why not to start from right to left, and once any hashtag found means one hashtag found means the next one character I don't want to include. Okay, see, earlier what's happening, you were going from left to right, you already added this, means you have used that some time complexity there to wait to add it. Once hashtag found, again you are undoing that, another time complexity, means O of 2n. Okay, now what I'm saying, why not to start from right to left? Once this character found, don't include that next one. Anyhow you are supposed to take O of n time complexity to encounter every character, right? So here we are not doing again and again for that undo operation. Okay, if it is hashtag, we are not including itself. So in just exactly O of n, although both are linear only, but here in exactly O of n time complexity and also space complexity. Okay, how we are saving space? See, in that previous one, we were saving every character in the stack and string builder. Here we will not do that. The idea is very simple. We'll start from C, it's okay. This is hashtag. Okay, means one character I have to skip because this is hashtag, so I will skip this. Can I say this? Yes. So now my I pointer will come here. Can I say this? Why? Because initially this I pointer was at C, as it was a character, so we went we did I minus minus. Now as it is hashtag, so means I can say, hey, one hashtag found means one character I have to skip. So means we have to do this count, like you have to keep a count also for how many hashtags we have found, because that many skips we have to do, correct? So one hashtag found at this I, so we will do 1 minus minus. Okay, 1 minus minus for one hashtag found, but by default as we are running in a for loop or a while loop, whatever we will choose, so for that already we are moving one behind, right? So one, like we are at hashtag 1 I minus minus because of the hashtag count and 1 I minus minus because of that normal for loop. I hope you get it. So now we'll stop. Similarly we will do from here also. See, its character, hashtag found means one skip, and one more because of that for or while loop, whatever we will use. Now stop. Now what we'll do now, instead of making or saving every character in another string builder using extra space complexity, here I know now that till now it should be same. That's what the definition of the problem, right? So if we stopped, means I am saying if we have encountered all hashtags and undo everything till now, like suppose there are more characters, C, D, E, F, I don't care, but here I stopped. Here F, G, H suppose, I don't care, here I stopped. So till now this is J pointer, this is I pointer. Is this ith and jth value are not same? No, it's same. So I can say till now everything is safe. Now see, the point we will hit this F, we'll stop, because we will only continue once hashtag found to undo. Otherwise we'll simply do I minus minus and every character we will match with the T. Very simple. So I minus minus F, J minus minus H. So now we'll see this I which is at F and J which is at H is not same. Okay. So what I am doing is, in just running one for loop for this S and one for loop for this T, I am going to actually match every character one by one. But the only condition is, once hashtag found, I already know now that this hashtag is going to delete this D and B. So if you will check every such character, you will say yes, B and D does not match. But wait, B and D will get deleted now because of these hashtags. So why to compare on this character? Like why to compare on this index, which we already know that it will be undo. So that's why whenever hashtag found, we'll simply go back and we'll skip. We will skip. And once we stop at some character where all the hashtags and undo operation we already did, now we will compare this character is matching or not. If not matching, we will return true, false, then and there. But to match also, this I character like I index and J index should be greater than equal to 0. What if the string length is smaller? Means this is to A, B, hashtag C, but suppose A is not there. So definitely this J is pointing to what? Negative index, and this is pointing to a positive index. So we will match when both index are positive. Can I say this? But here though it is not matching also na. So what we will do? This J is out of index, means one string length was shorter and one is bigger. So hence what we'll see, true or false? Obviously false. So these are the conditions which we will help us to use the space complexity as well, because we have not used any such extra space, because all the true and false condition we are going to just decide with the help of I and J pointers. So time wise it's linear only, but space wise it has helped a lot to save a lot of space. Means we are not using any stack and we are not using any extra string builder to make the string. So here's a simple code one by one. Let's see together. As we are running from right to left, so definitely I and J pointer will point from the end index, correct? Skip and skip T is nothing but skip S and skip T are just the counters to count how many hashtags continuously we have found, because that many times we have to skip the next characters, saying we are undoing that. Can I say? Yes. So now until this I and J are positive, what we'll do? We are adding this in another while loop. Why? Because this is just to encounter all such hashtags in S. Means suppose like initially, can I say my I pointer will be here? Yes. So now what I'll do, I'll simply check this ith character is C. Okay. So no matter, we'll simply do I minus minus. Okay. I minus minus. So now we'll point to I. Now here's the catch. What is this? Hashtag. So we will do skip plus plus, saying ki hey, don't match this ith and jth index value, because this will not be same, because now we are in undoing process. Okay. As this is skip plus plus, next time again we'll do I minus minus normally, and when we will be at B, we'll say hey, this B is valid or not, because skip is what? 1. Means this ith character na was need to be undo, because after that we found a hashtag, and because of that our stick is like skip S is 1. Okay, so we will what we'll do, we'll skip this by I minus minus, and now we will do, as a skip was plus 1, so we will subtract, and now skip S will become 0. Why? Because this character we already skipped because of hashtag. So we have not deleted anything from string, correct? So no extra space complexity. We are not forming any further string to match. Yes, only with the help of pointers we'll get that. Okay, so that is why it's very necessary to keep this much operation in a while loop, correct? Another reason is there is only one hashtag. What if multiple hashtags? Suppose hashtag after C 3 hashtags found. So we'll keep on adding this all hashtags. So skip S will become 3, and after that A and D. So all 3 numbers as per skip is positive. So we will delete. So for this much number of time, why to run in a single, the same while? Why not to traverse all this at once? Now if you're thinking ki this will take another nested while loop, will take another O of n. No, it's not. See, if you're running a single while loop also, you are going to traverse every index at once. And if you're running an inner while loop also, yes, you are skipping this much part. But when the outermost while loop will, continue itself, so it is not going to continue from this index. No, because this much part is already covered, so that outer while loop is going to start from this now. So hence all together it is running for O of n only. So that's what we are doing while I, this is for only S, remember that. This while loop is only for S. So while I is greater than 0, we'll check if that character is hash. If it is, I minus minus, and we'll do a skip plus plus, saying ki hey, this is a counter for hashtag key, these many times hash found. So once you encounter any character na, if the skip is positive, please skip that, saying we are undoing that. So else if skip is positive means that this character, and skip is positive means we'll do skip minus minus, means we basically are decreasing the count, and I minus minus means here is a basic undo which we are doing, okay? And once else means now this pointer we have to stop, because this is the exact index pointing to that character which we need to map or check with the T, if this is matching or not, correct? Now in the second while loop also, this we will also do the same, similar like how we did in S, we will do in T also. And once the I and J will stop, that index is exactly the point where we have to match if it is same or not. So what we'll do, if both are positive, means both index are valid. If it is so, and any such character is not matching, we'll return false then and there. Or else if any such index, I'm saying or, means what if one is positive and other is not, means other is negative, means the string is not equal length. So hence what we'll do, we will return false then and there. So we have written both the conditions for false, not for true. True we will only return once we have traversed every index from last to 0, okay? And now again we'll do I minus minus J minus minus for this normal while loop, okay? And at the end we will return true. So let's try to understand the same code with this example, and let's do the dry run for easy. If you understood, you can definitely skip, but not, then let's see for 2 more minutes. So here we'll start our I pointer, and here we'll start our J pointer, okay? So first though, with this character and this character is a normal character, and for this we can say ki skip is not positive and all, so we have skipped everything. So we will match this G and G. Obviously they're matching, correct? So we can say ki till now everything is fine, okay? Now we'll do this I minus minus. So we will do this I minus minus. So this will point to hashtag, and again this will point to hashtag. Okay, once hashtag found. So can I say this skip S will become 1 and skip T will also become 1? Yes, I can, correct? Now as this is 1, so definitely it will go to I minus minus and J minus minus as usual. But wait, do we need to compare this F and B? We can only do when this skip is not positive. This skip is positive means this character is not valid, means this character is, it will come in that undo operation because of the hashtag, okay? So first we will delete this. Why? Because skip is positive, correct? So basically we will skip, so we will move our I and J ahead. So skip will again become 0 and skip will again become 0. Now again, in this case, so it is valid, means A is waiting to match, but is this hashtag is the correct one to match? No. Again for this, skip will become 1. So we will do I minus minus. Again hashtag, skip will become 2. Again this D. Wait, this is our D character. Should we match this D with A? No. Because A is the valid one, because for this skip is 0. But this D is not valid one, because skip is D 2, correct? So as the skip is 2, means this D must have been deleted because of the backspace. So hence what we'll do, we'll skip this. Skipping means just move the I pointer behind. So what we're doing is now, for every, we are finding the exact ith character which is correct and jth which is correct, and then we will match. If no, not correct means if it falls under the undo operation, then that character need not to be matched, correct? So again we are at C and we skipped decrease to 1. Again C is a valid one? No, because skip is still positive. So we will decrease it to 0 and again we will skip this as well at hashtag, correct? Again hashtag. So skip will become 1, yes. So now what we'll do? Skip will become 1, so we will decrease this at B. Now is this B a good character, like valid character? No, it is not. Why? Because our skip is still positive, so means we will undo this. So as we will undo this, so again we will do I minus minus and it will point to A. So again, is this valid? Yes. Why? Because skip is 0, correct? So this was the idea, correct? So this A and this A, I and J. Now can we match? Yes. Are they matching? Yes. Can we say true? No, still not. In the while loop, again we will do this, like because of this while loop, I minus minus and J minus minus. Now the while loop will come out and then it will return true. And that's what we mentioned here, correct? Return true only when this outer while loop skips, correct? So now we can run this, and definitely the time complexity you can see total O of N for S and O of N for T. And as you can see, the length is 200, 200. So in total 200 plus 200, 400, okay? It's faster. Space wise, we are not using any such extra space, not using stack, not using builder. So this is the fastest solution, okay? So this was in Java, and if you are from Python, don't worry, here is your Python code. Similar approach, we have not changed anything, correct? And at the end we are returning true. Don't get confused if you are seeing this two nested while loop saying O of N square. No, no. Outer while loop was supposed to run for O of N, but inner while loop is helping to skip all such in between indexes. So once whatever indexes has been skipped by the inner while loop, outer while loop will also skip that. So hence in total O of N only. So this was your Python code, and here is your C++ code if you guys are from C++ background. With the same approach, you can take this screenshot here, okay? And if you understood the brute force means with stack also and the optimized one, how we optimize the space, then definitely you can go with me in the sheet and mark the very first question as done. Yes. And expecting you all would have understood, expecting a like and a comment and subscribe if not yet. Otherwise, it's totally fine. Why? Because this gives me more motivation to make more such videos for you all. With proper reasoning, why sometimes, even though we know this is from stack variation, but there can be a simpler optimized way as well. And that you can only come up with a lot of practice. But in the beginning, if you are able to think with a stack also, you are good to go. So that's it for this video, and I'll add the link of this free DSA sheet in the description. You can check that out. And if you want to connect with me on Instagram, LinkedIn and Twitter, all the links are there in the description. Do reach out to me if you need any guidance. And that's it for today. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family.